So first of all, we're going to talk a little bit about background, and then Matt will talk about some of the innovations. So first of all, we should just start with what is a PIT tag. So a PIT tag is a passive integrated transponder that has no internal power source. So these transponders will have a full lifetime of your subject, but it needs some kind of an external power to read that unique ID that's within that PIT tag. And that's where we start to leverage the transponder or readers. So the way that the transponders or readers work is they create a electromagnetic resistance within a larger field from this handheld reader, like you can see here in the green. And then it sends over to the PIT tag, which resonates at an exact frequency. And this frequency that we'll be talking about here right now is that 134.2 kilohertz. So what happens is the tag recognizes that frequency, and then it sends back its unique ID code. And this is much like these tuning forks, like you can see in this graphic. It sends out a specific frequency, listening for that frequency. And here it might be worth clarifying a little bit on some of the intricacies with PIT tags. So there's two different technologies here. There's full duplex, which has a continuous transmission, much like a cell phone, so each person can talk at the same time. And then there's a half duplex, which has this power listen alternation. So only one person can be talking at one time, much like a two-way radio. So it's sending out the signal and then stopping, letting off the trigger, and then listening. And some of the other specifics surrounding the full duplex and half duplex you can see in this graphic here, which include continuous transmission for the full duplex, typically smaller tags. The electronics are a little bit more complex, and it can read both at slow and fast read speeds. So if you're concerned with fish coming down through, or your animals coming down through an area and traveling very quickly past it, the full duplex is much better. The half duplex has that power listen, again, like that two-way radio, and they're typically bigger tags with a relatively simple installation and a slower read speed. So throughout time, there's been different frequencies of PIT tags. Initially, there was the 400 kilohertz, which had a much lower read range, and this was mostly used for terrestrial animals, and it was introduced in 1984 to salmon, but since the tag was actually plastic on the outside coating, there was water intrusion issues, which then compromised the tag. Fast forward a few years, and there was the 125 kilohertz tags, which read a few inches. They were still pretty good, a big improvement over the 400 kilohertz, but they were still not this ISO standard that we're using today. And as you can see here in red, those are non-ISO standards, and these 134.2 kilohertz are ISO standards. And this ISO standardization occurred in 1996, and it created a standard for all PIT tags to be read within a certain frequency. You can see here the half duplex tags have a read range of about 12 inches, where the full duplex tags have a read range of around 24 inches. So with time, technology's improved to where now we're near 2 feet of read range. So some of the different applications or transponders that we have are these handheld readers, like you can see in green here, an in-stream antenna, which you can see in the top picture, a Litz cord antenna, which is highly versatile, and it's a corded system. So you can create pass over, or you can create a loop and do a pass-through system. There's submersible antennas, which are fully autonomous, meaning that they have the battery and the reader all in one package. And those can be placed out at multiple different areas, and you don't have to worry about a power source on the bank or anything like that. And then lastly, there's a shielded antenna, which in areas that are very noisy, it can block out some of that interference within that same frequency range, such as at like a hydroelectric dam. So here's the big question is why should you update to the new technology? Say that you have the old 125 kilohertz tags. And the big reason behind this is that not all readers are created equal. Some of these readers that are older have a much lower read range, and they could be frequency specific readers. So they might only be able to read that 125 kilohertz range. The new readers have much higher performance, and most of the technology is driven at that 134.2 kilohertz within that ISO standard. This is also an area that would be good to clarify, that many of the in-stream readers, the submersible and the Litz Cord antennas, are all powered by a specific reader board that can only read the 134.2 kilohertz tags. And the way that we get such high performance is we have to only be listening to one frequency. Think of this like a spray bottle. If you neck this down and create a stream, it can go much further than if you tighten it down and have a mist listening to multiple different frequencies. You can't push the necessary amount of power to listen for that large read range of 2 feet. So that's why these readers only read the 134.2. And lastly, it's easy to double tag these animals. So if you have a long-lived animal like a sturgeon, and you have some of these older tags, such as the 400 kilohertz or the 125, you can read those tags, write them down, and then overtag that fish with a new full duplex 134.2 kilohertz tag, and use the newest technology while keeping all of that older technology as well. And with this, I'm going to switch over to my colleague, Matt, and he's going to be talking about some of the software technology innovations. Matt?
Awesome. Thanks, Nick. Well done. So we have developed some new data collection software that is pretty cool. And so this is the data collection module, or DCM, and this is actually a new wireless data collection that basically relies completely on Bluetooth. And so it actually Bluetooth talks to every single peripheral device. So Nick, if you go to the next slide for me real quick. So these are just some of the OS requirements that we have right now. We originally developed the software on the Android platform. And so when we started developing the software a few years ago, we basically started with Android 5.1. And so if you basically have a tablet already and want to basically load the software on there, it just needs to be Android 5.1 or newer. The cool thing about the software as well is that it has basically the ability to take pictures of whatever animal that you are tagging, animal or whatever, you can be out there tagging cactuses. And so you have to have an integrated camera in the tablet itself if you want pictures. It also has a really cool ability right now that it will actually take a GPS location of wherever the tag is scanned or wherever the record is made. And so if you want that basically capability, you also need to have a tablet that has an internal GPS. So we've messed around with doing some of the mobile platforms being like cell phones, and man, it just messes up the screen so bad. And so right now we have a minimum screen size of 7 inches. And if you want basically a good backup for your data, we always recommend like a 16 gig internal memory of the tablet as well. Last year, 2020, we finished development of the Windows platform. And right now there is a lot of really cool Windows tablets out there. We recommend like Dell or like a Panasonic Toughbook, just because they're number one, ruggedized already. The actual Dell tablets right now, the 7212 and the 7220, have a really cool hot swappable battery in the back of them. And so if you need extended runtime, you can actually have like 4 batteries for this tablet, and you have 2 of them charging in the truck, and swap the batteries out as you go. This one, I have not found a tablet with an 8-inch screen side that runs Microsoft Windows 10. So pretty soon, I guess probably they will come out with a smaller 8-inch, than an 8-inch screen that runs Windows. But right now, the 8-inch minimum screen size is right there. The 16 gigs of RAM just keeps it running fast. The 256 gig solid state drive just really solidifies basically the data collection well. And again, if you want the GPS and you want the image, you will need to have basically the integrated GPS and the integrated camera. Now, one thing that's important to note on these is that once you install the software, Wi-Fi is not needed. And so people ask me all the time if they need to get like a cell-enabled tablet. You do not. The reasons why is basically after installation, you only are basically collecting data on the tablet itself. Now, when you walk back into the building and you get like a wireless signal or something like that, then essentially at that point you can export the data off and then email it to yourself. We are working on a version 2 of this software that's going to launch either Q3 or Q4 of this year. Now, one thing that's going to be cool about that is it will have the ability to have a cloud network actually hooked to it. So we're working on a cloud database for this system. And so if you do have a cell-enabled tablet, then essentially it's streaming data off of the tablet as you're taking it. Or if you don't have a cell-enabled tablet, if you walk into the building, once you essentially have that Wi-Fi signal, it's immediately basically pushing data off the tablet. So we're working on that, and that's going to be hopefully by the end of this year. We're working quite hard to get that done. Nick, go ahead and go to the next screen for me. So as I mentioned before, this is a 100% wireless Bluetooth device, and so there's no more wires. No more losing wires, no more breaking cables, no more ripping cables, no more shutting cables in truck doors, because that's never happened. But the beauty of this is that every single one of these pieces, and I've went through over the years and identified a significant amount of Bluetooth peripheral devices, and this is just the start of it. I mean, this software's only been around for about 1.5 years now. And so obviously the first choice is going to be your RFID reader. I wanted to point out though that this software is not required an RFID reader. I mean, we're a pit tag company, so people think it's pit tag, only. No, if you want to go out and measure trees, you can absolutely do it with this software. And so it's a total open platform that allows you to hook any peripheral device to it, make any custom data field that you want. And so some of them that we've identified obviously is the RFID reader, and then we actually developed a new electronic measuring board. And right now we have it in 2 lengths available. That is a 50 centimeter and a 100 centimeter, so 0.5 meter and a 1 meter length measuring board that has basically 0.5 millimeter of accuracy. Scales were the tricky ones. Scales, we've basically worked with OHAS here and come up with, they have 2 new Bluetooth modules that allow you to basically hook your scale up to a Bluetooth device, and if you hit the print button on the scale, sends that data to basically the tablet. Calipers are actually finicky. There's only 2 calipers actually out there in the world right now. One of them is made by Silvac and the other one is made by Kern. No, Kern's a scale company. Anyway, there's 2 caliper companies out there, and I did a lot of research and come to find out they're the same. One's just sold in the U.S. and one's sold in Fowler is the other company. They're both, one's sold in the U.S., one's sold in Europe. We're having a issue with the Bluetooth staying connected. So essentially, as soon as the device goes to sleep, it actually disconnects from the tablet. But they work. They just don't work well yet. But we're working on it. We have a barcode reader, and this is actually really cool. All our new TSU tissue sampling units, which is our new genetic collecting platform, has a 3D QR code on the bottom. A 2D QR code on the bottom of it that can be easily read. And so this is what you're doing is you're taking all these different pieces and parts and you're collecting it all into the same tablet. So yeah, I mean that's the start of it right there. And there's probably going to be more stuff to come in the future. Nick, would you go to the next slide real quick? So this is kind of the whole thing laid out right there. Obviously, you see the MK25 implanter and the preloaded tray. So that would be your pit tag and RFID connection. The scale in the center section right there, that's actually the OHAS navigator with the Bluetooth module. You can see the little Bluetooth module hanging out the back of it there. The TSU, that is going to be the tissue sampling unit that I was speaking of earlier, and that's the new genetic stuff. The little orange handheld there on the left, that's actually the 2D barcode scanner from a company called Socket, that they actually design a ruggedized water resistant scanner. And then you see the big electronic measuring board in the front. That's actually the small one. That's the 50 millimeter one. And then that's the little Samsung tablet running the software there in the front. Now, the beauty of this, again, is we're not smarter than these handheld readers. We can't basically expect to take 13-digit hexadecimal numbers or 15-digit numeric numbers and not make mistakes here and there. So the reader does that for us. I basically tell this to everybody. We're not smarter than a handheld reader. You're eventually have some sort of transcription errors if you're still using pen and paper. The nice thing with the software too is that you can really make a lot of custom fields to it. You can make drop-down menus that for like quick acquisition, you can make certain fields what I call repetitive. And so if you're collecting, say you're on a raceway and you're collecting 5,000, you're pit tagging 5,000 fish that day, but you want to record which raceway you took them from and which raceway you put them in. So this is a super easy way. You can just make that data repetitive. So we took it from raceway 3, we put it in raceway 4. So you actually don't have to touch the tablet anymore. And so my goal was to make this software and tablet as autonomous, autonomous as possible. I wanted it just to sit there and basically collect data. With having to touch it here and there. And so there's a lot of really cool trigger features that you can do to it, where if you scan a tag, it creates a new record, then you scan another tag, it saves the old record and makes a new one. And so it just expedites the process much quicker. We tagged 50,000 fish at Chief Joseph Dam in 3 days and ran it through the software through its paces. And I could take 19 data fields and so we were scanning the fish, taking the pit tag number, taking a length, taking a weight, and also recording 17 other data fields, and I could process a fish every 3 seconds. So it really expedites the tagging process, and it eliminates any transcription errors. Could you go to the next slide, Nick? So this is kind of like a sample of the actual tagging screen itself. And so you see up there in the corner, you have the tag ID, SRR for verbose, that's a Agus nomenclature. It means species run rear. And so each of that, if you click on the SRR verbose, it'll bring up 20 different basically options. But this was just kind of an example of what the software actually looks like when you go. And so you can make like that station, you can make that repetitive. And so it just says station 1, station 1, station 1 until you actually change it. You see the little check marks next to the software right there. That indicates a valid field, a required valid field. And so what that is you can make certain fields required. And so for a good example, like species is probably the best thing. You're not going to pit tag every animal, but at the same time, you want to record what species they are. And so you could make that a required field, meaning that you cannot actually move to the next tagging record until that's field. So go to the next slide for me real quick. So once you've collected your data, now it's what do you do with it? And so we have it set up as to where you can export it out in an Excel file, a CSV file, and a text file. And you easily do that with just the button. And so you can upload it to, if you have like an Access database, you can, go Microsoft Excel CSV file, send that off, suck it into your database really quite easy. And then Nick, go ahead and go to the next slide. I think I've just got like a sample. Yep. And so this is kind of what your data looks like when it spits out. And this is just an Excel file that I spit out real quick. It gives you the time and the date. Now the time and the date actually comes from the handheld reader itself. It actually does not come from the software. And so a lot of people, you can do like custom dates, custom times. So if you wanted to do like a holding time and a holding temp, and then do like a release time and temp, you can do that in the software as well. But it's important to note that that actual data stream actually comes from the handheld reader. Now the count right there, what that is say you were out tagging Chinook, but you also want to just note that you saw 58 spotted sculpin that day. And so you could create a new record, and in the count menu up there, just do 58, and it would say, oh, by the way, we saw 58 modeled sculpin that day. Yeah, that's pretty much it in a nutshell. Obviously, I can go in for hours on this software and to the intricacies. And if you guys have any questions, feel free to email or call us, and I can set up kind of a WebEx meeting similar to what we're doing now and actually run through the software with you. I think the next slide is, yeah, and so this is our biologic site module software, which is actually something that's really cool. This was started actually as a project from my old company that I used to work for, but it's basically real-time monitoring of like your in-stream antennas. So if you have 10 antennas in the, somewhere extremely cold, and you're sitting in your office in Boise, Idaho, drinking a cup of coffee, and it's, negative 20 degrees on your antennas, you can simply log into your site, look at your site health. You can download any data that's like all your tag numbers. You can just basically pull all your tagging information and not physically going to have to go to the site. Now, this is actually powered via a cell phone modem or a satellite modem. So depending on obviously your cell coverage, the cell modems are much cheaper than the satellite modems are. But you can do it. You can do it either way. So this is actually a nice tool to have. And so these are the biologic site module is a monthly subscription, where the biologic data collection module is a yearly subscription. So these are all annual subscriptions, but fantastic software for, oh, by the way, we might have an antenna down. Oh, it's antenna 5. Well, what's wrong with it? Oh, we lost current on the antenna. Okay, well, that usually means something with the antenna is wrong, like a rock tumbled down and crushed the cable actually to the antenna. So this actually provides you with a lot of information to be prepared to go and make that 200-mile drive in negative 20-degree temperatures. So that's about all I got. Nick, did you have anything else you wanted to add?
I'd say the last thing to add here would just be, if you are in a system where you have some of those older tags, we do have one reader that does read all of these tags, and that's the HPR Lite. So if you're in an area such as the Great Lakes with maybe sturgeon, who have a lot of these old 125 kilohertz tags, if you get one of those HPR Lites, it will be able to read the new tags and the old tags. So if you're in that situation, just contact us here at Biomark, and Matt's a great resource on a lot of this technology.
Yeah, that's a good point. And I mean, we get that question quite a bit because the 125 kilohertz is not an ISO standard. And so unfortunately what happens is sometimes we run into the same tag ID multiple times. And so we don't play that game. We basically stick with the ISO ICAR certification, which guarantees that if the tag is a 134.2 kilohertz, the tag will be read by a 134.2 kilohertz reader. And then the ICAR certification guarantees that tag is never repeated. So the FDXA stuff, they don't have any of the certifications. So we have seen it in the past where you've seen multiple tag IDs. But I mean, that's the way it goes. The nice thing is that you can basically, like Nick was saying, double tag these animals. So to get the full performance out of our flagship tag, say the APT12 tag, that tag only needs to be right about a centimeter actually away from the FDXA tag. And the 134.2 FDXB tag screams so much louder than that FDXA tag does, the 125 kilohertz tag, that you will never, ever see that tag actually ever again. Now, to Nick's point when he brought it up that you want to record this information on the A tag before inserting, that's a great point, because I actually can't get an FDXA tag to read separately. So if you had like an FDXA and then you wanted to double tag it with an FDXB, they need to be around a foot apart on the animal to actually read both tags. So cool.
Yeah, well, thank you everyone for joining us today. And like I said, if you have any questions, just give us a call here at Biomark.
Thank you, Nick and Matt. We will now switch over to Gabe's portion of the presentation.
Elsa, your microphone's up.
It's off. Sorry, thank you.
There you are. I could just hear you, like it sounded like you were in the other room.
Excellent. So sorry about that. Let's move on to Gabe's portion of the presentation. So Gabe, I am making you a presenter, so you should be able to share your screen.
All right, that looks much better now.
Nobody's joined.
Yes, we do have a few guests in attendance.
Excellent.
Okay, can everybody hear me all right? And are we seeing the full screen?
We're actually seeing the presentation with your notes.
Okay, let's swap that over.
There we go.
You go.
All right.
Perfect.
Switch this camera real quick. I don't know if my camera's even working. I don't think anybody can see me.
No, we can't.
Okay. All right. Well, thanks for joining us. And yeah, I'll try to give some guidance on making the best choice for an in-river system. So this kind of builds on what Nick and Matt were talking about with pit tag technology and some of the developments, and we apply that. And I'll try to kind of cover some of the challenges, some of the limitations that we face here at Biomark. I'm a key accounts project sales representative, but also do kind of project management. So when thinking through how to choose your correct system for your application, I'll probably be one of the people that you can reference and talk to here at Biomark. We have a couple other individuals that are in the same role. So yeah, any of us here on the more technical side can assist you with designing your system. I've been going on about 7 years now, designing, building, and installing pit tag systems and applications all over the world. Really fortunate to share this information with you, and look forward to maybe speaking with you individually. Today I'm going to try to cover what data you can gather using pit technology, what kind of solutions we can provide, and then some real examples of applications for in-river monitoring. I'll do my best as well to relate more of a terrestrial application for some of these products, so that you have a better idea. Let's just say if you're monitoring wildlife, reptiles, birds, bats, any of this stuff. So I'm just going to go ahead and dive into here, into what kind of research topics we can address with pit technology and the systems we can provide. Basically, there's many research questions in which pit tag data can assist with answering, and I'll again try to kind of relay this into a wildlife perspective as well, so we get additional value here. So we can definitely help or assist in downstream and upstream long distance migration. We do this rather well in the Columbia River Basin, basically monitoring from the mouth of the Columbia River all the way up into some of the tributaries here in Idaho. Migration detection, again, we can give researchers or wildlife managers migration detection, and how the use of maybe side channels and backwaters are important to a watershed. And then let's just say in your watershed you have potential barriers. We can monitor both sides of that barrier and give you an estimation on whether or not your species are able to transition these barriers or move from one place to the other. As I mentioned, hydropower operation throughout the Columbia River and all over the world is very huge, and kind of makes a big problem for fish and migrating species to overcome these impassable man-made features. Habitat use as well, some distribution within a habitat. Maybe you're trying to answer some of those questions, and we can do a good job at kind of mosaically placing antenna systems throughout a watershed or a habitat, and give you that kind of data important to the habitat use. Survival and estimation, we do that all the time, just mark and recapture programs and filling that data into what you're looking for. And then the list goes on and on. Once pit tag antennas are in place, you can continue tagging fish and or wildlife at a relatively low cost, and do so for many years, right? As long as the system's up and detecting, if a pit tag goes over that interrogation site, you're going to get data. So let's talk about some of the challenges and limitations that RFID systems can face. And mainly, how do we determine how well our system's doing in antenna detection efficiency? Every biologist wants to have 100% detection efficiency, and in most cases, for especially in river systems, we can achieve fairly close. Efficiency can be variable over time. That can be due to environmental factors, power issues, all these kind of challenges that we face as technical services representatives talking to researchers in the field. You know, read range issues. But basically, antenna detection efficiency is determined by 3 variables, right? So river depth, the size of the monitoring area we're focused on, and especially in terrestrial application, the number of tagged individuals, and then the antenna read range. So what kind of performance we're getting out of our system. So let's take a little more in-depth look at these variables and see what kind of details we need to look for. So river depth, obviously this goes into, for the terrestrial applications, the size of plot that you're trying to monitor. You know, a deep river isn't very suited for RFID. We do have limitations on how much antenna field that we could emit from our products. So, you know, in deeper river or larger scale operations, the detection efficiency can be poor in the sense that the limitations of our products. We can propose some solutions to tackle these deeper rivers. Basically, you know, monitoring specific areas to get a more qualitative approach instead of a quantitative one. You know, the use of our submersible antennas, or you know, specifically looking at benthic behavioral fish in deep pools, or whether or not it's encapsulating maybe a burrow or a den. We can kind of focus on these areas instead of trying to monitor the whole river or the whole plot. Number of tagged fish. Now this is again more of a way to kind of increase our ability to nab these individuals as they pass over our detection interrogation sites. Definitely there can be a correlation between detection efficiency and the number of tagged individuals in your system. So this brief figure kind of goes over that, in which we're looking at detection probability on the x-axis and our bias going on the y. And we can kind of see here that we can achieve a good amount of detection probability by tagging, you know, an increased number of individuals. So another thing that I spoke about the variables about detection efficiency is antenna read range, and this can, you know, be something that's very important for a researcher. We'll need that performance out of that antenna to, let's just say in a river, to catch that whole water column and get a good sample of the individuals moving through. Read range can be affected by multiple factors. The first being electromagnetic interference. This can be from any sort of device, any sort of piece of machinery that's emitting some sort of frequency or harmonic of this 134.2 kilohertz. So what that does is the reader can't decipher sometimes the difference between electromagnetic interference and the actual tag signal. So the performance will actually decrease as soon as that tag signal gets stronger than the emitted noise coming from whatever source that may be. Then we'll get detection, but until then, we'll have some troubles detecting that. You know, some of the electromagnetic interference can actually ride in from our power source. So that's where we have to be mindful about how we're powering our systems. Sometimes when we're on grid or mains power, we actually have to filter that, isolate that circuit in order to remove that conducted noise into our system. Pit tag orientation is very important with RFID. In most in-river applications, I would say we're in pass-by orientation. So that's the antenna running basically perpendicular to our antenna field, where, and I'll switch over to this display, it's a little bit easier to to grass, where pass-through orientation is actually cutting the plane into the center of the antenna. And we do see some difference in read range based on this orientation, this tag orientation. So we can see in the graph here that pass-through orientation is actually a little bit better performance out of an APT12 than in PI. Just as important is our setup on how we're powering our antennas, right? So as you can see down at the bottom, that is the exciter cable length. So connecting your antenna to the reader, that distance in between those two devices, basically a reader and antenna, the longer you get out there in exciter cable length, the decrease that we can get in read range. So looking at how to design an antenna system, we're going to look at these variables, right? Depth, river width, and again, in a terrestrial application, this could be the scope of your plot where you're trying to monitor and how to do so. In stream, we're looking at water velocity, how fast are these fish moving, and then specifically for pass-through antennas, we're looking at the debris load. But also has a big impact on pass-by antennas, because if we have a big bed load movement within a stream, keeping those systems in place can be an issue. Again, we kind of talked about electromagnetic interference. You know, when we're selecting these sites, we want to think about accessibility and safety. How easy is it for us to be able to get to the site, number one, and then safely work there? You know, we also got to think about the power supply again, whether or not AC power coming from, let's just say in most applications, it's never a good power source. It's usually a shack or a shed or a GS station where we're pulling some power or getting permission to use there. You know, we do offer alternate power sources, solar and thermoelectric generators for those in really remote situations. And then we can provide this, you know, ease of access to your data via remote communications, via, you know, SAT modem or cellular modem. Yeah. So in choosing which antenna you may use, you know, we're going to dive more into the in-river type system here, but we also work in the facilities, hydropower plants, fish ladders on a diversion dam. We do all sorts of different stuff, as well as terrestrial applications. You can see Mr. Penguin here looking all hot and bothered that he's about to jump over the tag. So yeah, we have a lot of solutions for your monitoring needs. But let's just dive into the in-river. So pass by, again, what you see in the picture is an array of 20-foot antennas extending across the stream. We also have the pass-through orientation and floating antennas, and that's basically you know, what your application may call for. We've got solutions for all of it. So let's look into a couple of these. I'm going to skip over some of that. So in a pass-by orientation, you know, we generally apply these to wide and shallow rivers. That doesn't mean that you may have some deep sections on your river, and we try to choose locations to deploy these antennas in applications where our water depth, you know, is within the constraints or capabilities of the antennas. We want to be very mindful for you know, keeping our system safe. So, you know, in the event that we have a flood or something like that, we want to make sure the antennas are well placed and then the electronics are out of harm's way. You know, we have to think about debris load, especially in pass-through orientation, but also for, you know, root balls or anything like that coming downstream that they may grab a hold of one of these antennas and take it for a ride. The pass-by antenna also helps with vandalism, although it's not fail-safe. But we try to mitigate all these different challenges that we may face in deploying some of this, you know, equipment. So pass-by antennas again use our high density polyethylene pipe antennas. We wrap a simple coil in through these pipe structures in order to be safe and provide adequate read range. They're available in 3, 4.5, and 6 meter lengths, so 10, 15, and 20 foot lengths. And this is how we kind of, I guess, cover the length or width of the river. So how do we accomplish individual antennas across a river? That could provide you with a little more resolution than just extending one single antenna all the way across the river. So if you want specific information on what part of the river these fish or whatever species in terrestrial application are using, we can multiplex multiple readers together using this IS-1001 master controller that you see in the center of your screen. And off to the left there, you can see that each antenna is individually attached to an IS-1001 reader that powers and creates that electromagnetic field that the pit tags have to go over. The master controller by itself can operate up to 12 IS-1001s, and then will be your single source of data. Will provide date, time, tag code, reader ID, which then correlates to antenna ID, and then your master controller ID. These can be synchronized, so master controllers can be synchronized so we can use more than 12 antennas in certain applications, and we've done that quite a few times all over the world. One of the, I think, largest antenna systems we have out right now is 20 antennas across the river in California. In thinking on how we kind of secure these in place, how do we keep antennas in place for continuous monitoring year round? We use a duckbill anchor like shown on the right hand side there of your screen, and then we use either pneumatic or hydraulic tools to drive those into the substrate and then secure these in place. So another option and kind of a newer product for us as project sales is the Litz Cord antenna, available in 9, 12, 18, and 24 meter lengths, so 30, 40, 60, and 80 foot, and that's loop length. So that is what you're extending all the way across your monitoring area. And as you can kind of see in some of these pictures, we've come up with a unique way of securing this in place. We use more of the ladder rung style with a hole in the middle, and you can see kind of the shorter small anchor in the top right. And these are a great product to use for let's just say you're gonna monitor for 6 months of the year. This would provide you pass-by detection. We can do it in pass-through, which we'll see here in a minute. But a good, I guess, cheaper route other than using, a 10, 15, 20 foot fixed HDP antenna. We can cover a wide array here with a Litz Cord antenna. Another option for pass-by, one of the products that I'm pretty proud of and was able to be in the development for, is the Submersible Antenna. And previously we used a smaller reader, but we've actually upgraded the system to an IS-1001 reader, which will again read both FDX and HDX tags. It's fully autonomous. It's got the battery pack, as you see in the left picture there, available in a kind of smaller pack. I think it's a 72 amp hour, and that lasts about 2 weeks out in the field. And then the larger pack, which can last over 30 days. I think it's roughly about 34 days. Submersible antennas are available in just under a meter, 1.5 meter, and 1.8 meter options. So the fixed lengths or fixed antennas, as you see on the left there, are in 3 foot and 5 foot lengths or widths. And then a collapsible version, which you see on the right there, is a 6 foot. And what's nice about that, it's kind of modular. It's got quite a bit of hardware, but it can be packed up and put on a pack frame or a backpack, hiked into remote areas. And then we're, again, mosaically placing these within a habitat or stream or deep pool or something like that to be able to monitor, let's just say sturgeon, right? This product, I think, developed with bull trout habitat and sturgeon, and it allows us to get good data for individuals that are long-lived and hang out in hard to monitor areas. Another picture here of the older version. This was the RM310 version, so a little bit lighter of a reader and not as much performance as what we see in the IS-1001. The last kind of cord antenna system is more of our lighter version of the Litz cord antenna. It's just a small scale flexible cord. It's a 50-foot length, but that is linear, so it's a 25-foot loop length. And these systems are great, especially in terrestrial applications. We use this a lot in bat research, rodents, reptiles. A lot of research use these. We can manipulate the configuration of these antennas in order to really seek out entrances or burrows. It's good too for salamanders or any pond-like applications to where we just need to monitor a section of the bank. So yeah, this is a really good versatile product. So let's move into pass-through antenna applications, which generally are for smaller, more stable river systems with no major debris or ice load issues that we'd be thinking about. Culvert applications, road crossings, we can kind of amend these to a whole lot of different applications. We can do it in a few different ways. Again, we can use the high density polyethylene pipe, so we can customize the width and height of any of these applications to kind of meet your needs. We can do it with the Litz cord antenna, which again is available in the 30, 40, 60, and 80-foot loop lengths. What's convenient in pass-through orientation as well is that we can actually multiplex multiple systems. So, and I say multiple meaning a pair of systems or antennas, to where we can use an upstream downstream interrogation arrays with two Litz cord antennas, as you see in the picture on the right. In the middle there, you'll see it's got a small kind of junction box. This was a picture of kind of the first rev of the junction box, but now we have a fully submersible application that could be, underwater if necessary. Kind of the last in-river application I want to go over is our floating antennas. We have a couple different options. These are great with rivers that fluctuate in water level, where we want to focus more of the surface of the antenna. And then, they can actually be combined with a pass-by system more at the substrate level, and we can float these floating antennas over the top so we can get the full water column. We have a couple applications here. As you can see, we've made a kind of a Raft system with multiplexing two of the inflatable floating antennas with more of a river raft style, to where we can float down the river and do simultaneous monitoring. The rigid floating antennas can be multiplexed off a master controller, and as you can see here, monitor certain areas within the stream. That's a pretty high velocity application that we have in the picture. Okay, so I basically covered some pass-by, some pass-through, and some floating applications, and how we go about monitoring those locations. There's all sorts of different ways of achieving monitoring, and I think we do a really good job and take some creative ways to solve your monitoring solutions. So definitely let us know if you know, there's something specific that you're looking for, and we'll be more than happy to come up with some sort of solution for your monitoring. Kind of some key takeaway. We need to maximize read range when we're thinking about how to design these antenna systems. We want to tag a lot of fish to give us the best or to mitigate bias as much as possible and give us a good chance at getting good data, and then use the most suitable antenna to that application. Some of the benefits of our Biomark IS-1001 reader is it will monitor both FDXB and HDX tags. It only does read 134.2 kilohertz, but you know, I think we do a good job at providing an auto tuning reader that stays within that 134.2 kilohertz and effectively monitors without a lot of attendance to your systems. And I think that's pretty much what I wanted to cover. As you can see, there's my email address there. If you'd like to contact me directly, you can visit our website as well or call our customer service line. I appreciate you taking the time to hear about all the information I've presented. And yeah, just please reach out and let us know if we can help with your study. Thank you.